Can I show you guys something really quick that I just showed Alan, which is kind of useful? So, real little trick. So, you know, if I say h equals this, h becomes a hash with nothing in it. And if I say h sub hello, I can assign a value. So if I type out h, it's like that. But if I say h sub goodbye plus equals 1, I get an error because h sub goodbye has nothing in it. So you may say if h has key goodbye, then blah, blah, blah. But instead, if you said h equals hash dot new, then the argument is a default to return for any unknown key. So if I put 0 here, now whenever I say h sub foo plus equals 1, because it automatically created an entry for foo and set it to 0. So very handy, saves a lot of complicated if-then else's. Okay? That's it. Questions? Okay. Return. Yes, yes.
So if I want to the hash value of the hash table to be a different
Another hash, that's fine.
So
You,
I could,
yes, you would do like this. Cool, oops, cool equals hash dot new, and you could even say of that dictionary that you want the default to be 0. Okay, so now I can say cool sub foo sub Brandeis plus equals 1. Okay, yes?
in the movie has an expression for
For non-hash key.
not has key.
Oh, not has. Yeah.
I didn't find it.
Well, just say not has key. In other words, you'd say cool dot has key foo. Oops. Okay, okay. Right? And then you go. Gotcha? Anything else before I turn the screen off again? All right. Yes.
I'm so little confused about the this notation here. It's a symbol notation, right?
Yes.
You know, in here, like when we define a hash table,
Yeah.
the symbol notation is like it's not a variable. But here, you know, we have this kind of attribute reader. In
Yeah,
here,
it's
we know
yeah,
an arrow.
it's not a variable. It's actually, if you think about it, adder reader is a method, and those are parameters. Because remember, you don't need parentheses around parameters. So actually, it's an argument with a variable length. It's a method on class, which allows 0 or more parameters, and the parameters are all symbols. And in the body of that method, if you looked inside the Ruby interpreter, you would see a loop that for each one of those created two methods, a reader and a setter. And we call this metaprogramming. When you write a program that modifies a program, now you don't have to do that. It comes with the language, and people often see that and they get confused. They think this is a regular statement in Ruby and it's an extension to the syntax, and it looks that way, but really it's a library. It's very cool. Yeah. Yeah. Okay, real quick. So I'm showing you a very simple tool in Ruby called the benchmark module. And let's say I wanted to compare the performance of looping one I in 1.n with n times with 1 up to n, which are all different ways of looping from 1 to n. I would surround it in a block benchmark.bm do x, and then I would do x.report for each experiment, and it would generate printout that looks like this, where you would see experiment 1, the total times was almost the same. So you can see here they're not performing differently. If you want it to be a little bit prettier, you'd say here 1 dot dot n. Here you'd say n times. Here you'd say, this is just documentation, up to, like that. And then I think if you run it now, here's the output, and it's a little bit clearer to see. If I pull this out, we see the experiment 1 dot dot n performed like this, performed like that. So what you could do is you could use this and put it in your algorithm and get a timing for each file in both cases, and see which of your different loops is the one that's hurting it, and that'll help you figure out why it's much slower. The fact that it's slower with a smaller file, but the processing is different with the smaller file, right? Am I right? The big file and the small file, are you processing the same thing, and one is slower, and the small file is slower, or are you doing something different?
It's the same thing, same algorithm, two different files.
Okay. So that's what I would do, is I would try to isolate where if you can't find it by just inspecting your code and thinking about it, then you can just do some timing. But certainly it's the sign of something weird, and I would suspect a real bug, not just something weird, because it's very counterintuitive. But check this out, it's really simple to do, and it's just a quick way to get timings.
Which benchmark.bm?
There's a bunch of different ones. If you want to look at there's a whole family of, that's the easiest one. There's benchmark.bmbm, which does what they call a preheating of the algorithm, runs them all once and then runs them again. Takes 2 passes through the test, then calculates the required label width. And then there's various other variations, but benchmark.bm is the generic one. And it's a very, very simple thing, but it's, it's handy. Saves you the time of subtracting milliseconds and printing out and stuff like that. All right, I think I got this right. Okay, so basically locally you go to the project directory, you do git init, which tells it turn this project directory and its subdirectory into a git repo. Okay? Then you code. Then you do git add all, which then says all my files and my sub files are now are now being tracked by Git. Then you do Git commit -m some commit message, my first commit. Now you have a commit locally, but it's not yet on the server. On GitHub, you create an account, obviously. You create a repo with the same name, whatever it was, my file. Give it a name. These are not commands, these are like in the UI. And then it'll give you a couple of commands to give on this side to connect it to. And then when they're connected, you do git push. And whatever you've got in the commit goes over. So those are the commands you need. Yes? Git init takes a directory, what I call your project directory, which is whatever, let's call it movie stew, which is in your blah 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 directory, and it may have a data subdirectory or whatever it is, and files.rb, whatever, readme, whatever. The point is, the whole blob starting at your project directory is now, by doing git init, turned into or properly formatted to be a repo. In reality, if you look closely, what it does is it creates a hidden directory called .git. And the presence of that hidden directory is what says that this whole subdirectory is a Git repo. And once you have this, these commands are allowed. Until you have this, these commands will be rejected, saying this doesn't look like a repo.
Because what I did was I just started from GitHub.
Okay,
And I just did git clone when it just had a readme file.
that's fine. So what you've done is you started here, and you created an empty Git repo on your computer, and then you put the files in there. That's the same exact thing. You just start from the